Okay, right? Yes, I have started what the failing reagent, right? Oxidation by failing solution. So, what is the composition of the failing solution? Yes? Anyone? Quickly? Just now I said. What is the major composition? Yes? Copper to tartarate. Okay? With sodium aqueous solution is giving the failing solution. So actually what is happening? Your color of the failing solution is dark blue. Right? We have the failing A, failing B. That is another, when you perform the reaction, we use to state failing A solution one portion now, failing B solution another portion. The half of the portion of few drops of what? Your aldehyde. This is what the performing way of the reaction. Alright. So here we are just talking as a failing solution. Don't confuse here. So once you take this failing solution, right? We are going to add few drops of aldehyde as it is dark blue in color. So we are going to subject to heat. For heat purpose, we are using the boiling tube. Right? The color of the dark blue will disappear and it will appear as what? Red coloration. Finally, you will end up with brick red precipitate. This is the very important. So the why this brick red precipitate form, your copper, you have what was there? The copper 2 tartarate is converted into cuprous oxide, Cu2O. You can say that is as cuprous oxide. Are you all clear? Are you all clear? Again, I am telling, right? Just look at here. The oxidation by the failing solution. The failing solution is containing the copper tartarate, copper 2 tartarate along with the sodium hydroxide. So what is this? The solution of the color of the solution is dark blue. Once you take into the boiling tube the failing solution, we are adding the few drops of the aldehyde, right? And you have to subject to the heat. Once you heat, this is the dark blue color, it disappears. Then it will form the brick red precipitation. That is very important. You have to mention the brick red, right? That is the formation of cuprous oxide, Cu2O. Copper 2 tartrate converted into the cuprous oxide. That's why the dark blue solution converted into brick red precipitation. Are you all clear? And this is what we are using, right? If you want to distinguish aldehyde and ketone, we can able to react with the failing solution, can make the further confirmation about what the aldehyde is. Are you all clear? If you say clear, then only I can. Am I mute? Not right. I can write the reaction. Is it clear? It's a practical stuff. Is it clear? Yes, guys. Hello. Hello, are you there?
Yeah, yeah.
Yes, madam. Yeah, yeah.
Please speak, guys. Please, 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 right? So is it clear?
Oh,
Why? Still thinking, processing.
no, Miss, ridiculous.
Clear,
Please
right?
repeat. Yeah, Miss.
Okay. I have found the video. Okay. After completion of that, I can share it. Okay. Right. So let's rewrite the reaction. Actually, what is happening in the reaction? You have the aldehyde. What is your aldehyde? R C O H, which is reacting with what? The copper 2 tartrate. Okay, the copper 2 tartrate you can say Cu plus. Sorry, 2 plus. The tartrate ion, right? Plus OH minus. That is also that. And ultimately you will get, again I say, the salt of the carboxylic acid plus cuprous oxide CuCO plus water. And this cuprous oxide is subject to what? The clear observation. What is that? Brick red precipitate. So here again I am telling the aldehyde reacting with the copper 2 tartrate ion. Copper 2 tartrate ion. You can write like this because your reaction is given like that, though it is a complication, right? So copper 2 tartrate ion in the presence of the sodium hydroxide. This is what we are telling as the failing solution. Right? You will end up with salt of carboxylic acid and formation of the brick red precipitate Cu2 plus water. Are you all clear? Okay? Is it clear? Shall I go for the next heading? Yes, guys. You have to say clear, then only I will know.
Clear.
Yes, Shahim. Okay, right? So we have done what? The oxidation of aldehyde by the Dolan's reagent and the failing solution. Now we already studied the common oxidation reagent. The common oxidation reagent. Who are they? The oxidation by oxidizing reagent. Yeah, you never forget, right? Reagent. So actually what is happening? The aldehydes react with one of the oxidizing reagent. In acidic medium. Permanganate, dichromate, chromic acid. And you will end up with carboxylic acid. So let's write an example. Your aldehyde RCO. Okay, here we are going to speak about what? The dichromate and the permanganate. So what should be the reaction? Let's say write the reaction to you. Right? When the aldehyde react with the dichromate ion, dichromate ion Cr2O7. it will end up with what? The formation of Cr3 plus solution. Actually, what is happening? The aldehyde doesn't have the color. Your dichromate having the color, that is the orange color. The orange color transfers into the green color. This is what is correct. So let's rewrite the reaction. The aldehyde reacting with your dichromate ion. Right? What is the color of the dichromate? That is the orange in color. And you will end up with what? The formation of carboxylic acid. The formation of the carboxylic acid in the presence of the Cr2+. Here the solution is orange in color. That should be transferred into the green color. So this is what is the observation. Now the aldehyde is oxidized to carboxylic acid by changing its color. Earlier it was orange. After the oxidation it turned into green. You can further confirm the oxidation happened in aldehyde. Did you understand? Did you all understand? Are you all clear?
Miss, it will happen suddenly or like slowly?
Now once you mix the color, I will show you. There is a video I will leave the video now. Okay? Right? Clear?
You show now?
Inshallah. I'll first tolerance. Then this thing I'll show one by one. We have
Okay.
much time. Tomorrow also we are having time, but we can finish the fortnight examination paper. I'm not going to discuss about that meta para, that is you can see and write. The most only the reaction part I want to do the paper. Okay, are you all clear? This is for what? With dichromate ion. So what about the with permanganate, where the aldehyde reacting with acidic permanganate, that is they are telling is as a pink color. We used to say it's a kind of the purple color. Here we mention as a, they are telling as a pink, so we'll write as a pink. Okay, the pink color. It will form the carboxylic acid with Mn2+. The pink color turn into colorless. The example is the aldehyde reacting with your permanganate ion and giving off the carboxylic acid RCOOH with Mn2+. Actually, your color of the permanganate is pink color or purple color, like purple color, which is transformed into colorless. So simply they are telling is, when you have the aldehyde, if you add, right, if you have the solution of the permanganate solution, if you add the aldehyde, the color, the pink color will disappear. It turns into the color. That is the observation what the aldehyde completely oxidized into carboxylic acid. Are you all clear? Are you all clear? Is it clear? Yes, guys?
Yes.
Thank you. So actually, previously I said aldehyde only oxidize. Ketone never oxidize. What is the reason? What should be the reason? For the oxidation part, we need the hydrogen.
Double bond.
Hydrogen right here. Okay, the carbonyl group double bond you are saying. the carbonyl group, there should be a hydrogen for the further oxidation. Though you can see the aldehyde has that hydrogen, but ketone you have only 2 alkyl groups, there is no hydrogen. It's not possible for the oxidation by using these oxidizing reagents. What we study now. But under further condition, the ketone will react or can be oxidized. Wait. Yes, I'll clear it. So the ketone, we say, just with permanganate ion and this dichromate ion, it won't oxidize. Why? It doesn't have the to oxidize. They should have the hydrogen. They don't have it. Therefore, they won't oxidize. But when you use this ketone along with the oxidizing agent, okay, if you heat, they will undergo for the oxidation. Right? Such oxidation, what is happened? The carbon-carbon double bond. This is what the actual bond of the ketone, right? Right. This carbon-carbon double bond, the carbon-carbon bond will break down and you will end up with decomposition of. Decomposition of. Okay. Decomposition of the ketone. Did you all understand? Did you all understand? Is it clear? Is it clear, guys? Are you all clear? Yes? Is it clear? Okay.
Yeah.
So
Yeah.
simply, okay, I'll stop sharing and I'll find and I'll start the recording. Mute your mic, guys. Okay, now we are going to look at Tollens reagent is for the aldehyde. That is, we are calling as the silver mirror test, right? Just look at clearly.
Using Tollens reagent to test for aldehydes. The silver mirror test. This video demonstrates how to use Tollens reagent to test for aldehydes. This video first demonstrates the preparation of Tollens reagent. Two tests will then be carried out. One shows a positive result, and the other shows a negative result. Preparation of Tollens reagent. Add 2 ml of 0.3 molar silver nitrate solution into a clean test tube. And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution. Brownish precipitate of silver oxide will be formed. Enter 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved. Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as Tollens reagent. Add a
Card
small amount of sample to the Tollens reagent.
Sorry, you couldn't see. Mm.
And then add 1 to 2 drops of 0.3 molar sodium hydroxide solution. Brownish precipitate of silver oxide will be formed. Add a 3 molar aqueous ammonia solution drop by drop with a dropper, until all the silver oxide precipitate is just dissolved. Do not add excess amount of the ammonia solution. The solution obtained is aqueous diamine silver solution, which is also known as Tollens reagent. Add a small amount of sample to the Tollens reagent. Shake the mixture gently, and then stand it on the bench for 10 minutes. Observe if there is a silver coating formed on the inner surface of the test tube. If there is no observable change, warm the mixture in a warm water bath for 5 minutes. If the sample is an aldehyde, a positive test result will be obtained. If the sample is not an aldehyde, the test will give a negative result. It is important that Tollens reagent should be freshly prepared. Prior to disposal, the reagent must be acidified immediately after use. The addition of acid prevents the formation of explosive silver nitride.
Okay guys, video I stopped, right?
Yes.
Is it clear now?
Yes. Yes.
Simply, right? Actually, this is what now you can visually see what is the silver image. So they said it's really important. The preparation of the. Can you hear me?
Can hear. Miss, can you send that video link in the YouTube WhatsApp group?
Okay. Now, okay.
Not now.
Okay, I will do that one. I'll send it.
Later.
Okay, if you type also, there is should be the first video, and that is the good video I have seen. Okay, right, I will send you. If not, please remind me. Yes. Okay, go, Baba. Right, so it's simply said you have to go through very carefully the addition of the preparation of the Tollens reagent that should be freshly done. Otherwise, you can't. It's end up with a mirror image is not that much easy. Your silver nitrate should be very pure one, and what you are doing addition of the NH3, the dissolving part, those things should be very conscious while doing the practicals. And now we are going to use the videos of failing gauge. Give me a second. Hello and failing test aldehyde. Okay, right. Okay, guys, now I'm going to share the failing test, right? Yes. Now, stop share. I have to share with some. Yes. Can you see the big screen?
Yes, madam. Yes.
Can I
So
hear
this
the
is going to
sound?
be a test for an aldehyde.
Can I hear?
Yes.
Thank you very much. Let's move on. The recording is there, right? Okay.
So this is going to be a test for an aldehyde. Here I have some Valence A and some Valence B solutions, and I'm just going to mix equal amounts of those to produce our Valence test reagent. Obviously you should do it much more accurately than just using little plastic pipettes, and you can see that after I mix it, this is going to be a lovely, lovely dark blue solution. So here I have some sodium carbonate, and I'm just going to take 5 drops, 1, 2, 3, 4, 5 drops of my Valence test solution in there, and I'm going to add the aldehyde and heat it. I'm just adding in my aldehyde sample, and then I'm going to heat it. So here is my sample that I'm heating here. Already we can start to see a colour change at the top here. And now we can start to see the red colour coming through. So this is the results of our test with Valence solution. You can see that it's got a horrible brown, dull, murky precipitate. Not very nice at all. This is the test for an aldehyde using Valence solution. So here we have here for German aldehyde. It doesn't really matter what it is. In the important part in the Valence solution that we're looking for, these are the copper ions, and in this state they are blue. After the reaction has taken place, the copper ions are going to have reacted and are now going to be red. Although element is more of a browny mud colour. Thank you for watching. I hope you found this helpful. Subscribe so you don't miss any more of my videos.
Sorry, I was muted. I didn't see. Are you all clear? Yes?
Yes, yes.
So this is what he said, the color transformation.
From blue to sun cook.
Okay, right. And give me a second. I will send. Next one is reaction videos. oxidizing manganate. Oxidation alkene, not alkene, manganese oxidation of aldehydes. Yes. Okay. And your final video is there. Yeah. Can I see the full view of that video? Okay, and
Yes.
you can see here, this is what the dichromate orange in color, right?
Yeah, yeah.
And this is the
Same one, no,
permanganate.
purple in color.
Yeah, but your syllabus they are telling is pink color. Purple color.
I don't know why.
Yeah.
I think the one who wrote the syllabus have color blindness.
So but if it is become more diluted, it should be kind of the pink color. Maybe for that, but actually it's dark purple. Right, okay, so I will share the video. Just look at what they are. He is going to add what? Aldehyde, and you can see the different coloration. So just look at your eyes. This is your permanganate test tube. This is your dichromate test tube, right? Okay, what was the initial color permanganate? It's a purple color. Your dichromate is an orange color, yellowish orange, right? Now this person going to add the aldehyde, and what should be the color transformation? Here, the dichromate will transfer into what? Yes, colorless. Sorry, not dichromate. Your permanganate transfer into pink to or purple to colorless, and your dichromate orange or yellowish orange to green. So this is what you are going to see here. Yeah, you have 4 minutes. This is just a 1 minute video. So let's watch the video.
Aldehydes are oxidized by potassium manganate 7 to the corresponding acids. As the reaction proceeds, the purple color of manganate 7 ions fades away and a dark brown precipitate of manganese 4 oxide is formed. Aldehydes are also oxidized by potassium dichromate 6 in acidic solution. The orange color of the dichromate 6 ions changes to green, which is characteristic of chromium 3 ions.
So have you seen, when you use the permanganate, right, you can see there is a precipitate. Here we are speaking about the color of the solution. Your earlier color is the purple or pink color, which is transferred into what? The colorless, turn into colorless. That is the precipitate formed due to what? The formation of manganese oxide, MnO2, right? The color of the solution you have to check. Here, the orange turn into green. Are you clear? Is it clear, guys? I'm not muted, right? Yes. Is it clear?
Hi Chem 245 students, this is experiment 7, which is the reaction of aldehydes and ketone. We will start with part 1, which is...
Actually guys, this is 20 minutes video, right? I just started. Maybe action of the aldehyde and ketone. You just Google and see, check your YouTube, right? Just have a look what type of the videos are present. So there should be plenty of different videos, so you can have an idea about how the transformation happens. Are you all clear? Okay, this class finish, again we will start the class. Okay, so now I have complete that aldehyde ketone.
Again, what time will class start?
Huh?
Again, what time class start?
Again, what time class start? Shall we continue? We will finish at need break. No, I said I will give you break. No,
Madam, you said 11:45 class finished now.
yes. Now it's 11:10, right? 15, right?
Okay.
So you need
We'll
break.
take a 5 minutes break.
Why? 2 hours.
Take
I
10
said
minutes break and come.
for 3 hours. I
Madam,
will
you
say.
tinnala, madam.
I also didn't eat. From
You
morning.
also eat and come, and we'll also eat and come.
I'm not eating morning. Not 10 minutes, okay? It's 11:45 now, ma'am. Just another half an
Then-
hour more.
5 minutes I will take, madam. 5
Okay,
minutes.
5 minutes, right? Now the class will finish, okay? The time is 10:11. I will start at the 10:17, right? Be on the line, okay?
Okay.
Okay. You can leave, guys. Leave and go. Bye. Assalamualaikum. Come, ma. Within 5 minutes.